In this video, we will discuss a problem based on blocks, tension force, normal force, and Newton's second law. So here we have a block 1 of mass 3 kg is on horizontal surface and is pulled at a constant velocity to the right. Constant velocity means acceleration is 0, so F net is equal to 0. That is sigma F, which is F net equals 0. Block 2 has a mass of 1 kg and is on block 1 and it's held at rest, so it's not moving. Coefficient of static and kinetic frictions are given to us. Kinetic is 0.2 and static is 0.4. What is the tension in the string attached to block 1? So first we will draw the forces acting on block 1 because that's what we are focusing on. There is a tension force to the right and there is a friction of the table to the left. Also, because block 2, even though it is at rest, when you are pulling block 1 to the right, there will be a friction from the top block also, that is block 2, which is also to the left. So the relative motion is to the right, so the frictions are to the left. Now Newton's second law says that sigma F should be 0 because object or block 1 is moving at constant velocity. So we can write tension minus the frictions, the two frictions should be equal to 0. Now remember, block 1 is moving. That means it's kinetic friction, which we are going to take. So let's just write the formula for friction, which is mu Fn, but I'm going to write it as mu K as its kinetic friction. Fn block 2 minus mu K Fn for table. So we have to check what's the normal force in the case of table and in the case of block 2. So again, going back to the free body diagram, block 1 is on the table and on top of it there is block 2. That means there is a total of 4 kg which is pushing the floor or the table down. That means the table will push up with the same force, which is 4 times 9.8. So again, because block 1 and block 2, so block 2 is kept on top of block 1, so the total mass is 4 kg and this 4 kg is going to push the table down, and that's why for the normal force of table we are going to use 4 times 9.8. So then now to get the normal force of block 2, we have to go back to the diagram. We can see that block 2 is on top of block 1. It is going to push block 1 with its own weight. So it will have a normal force of the same amount, which is 1 times 9.8. Now that we have got the normal forces for both the floor and for the block 2, that is for the table and for block 2, we will substitute that into the equation, solve it to get 9.8 Newton, which is approximately 10 Newton, and I think in the multiple choice we had one of the option as 10 Newton.